I am the piano tuner here, and as he mentioned before that, Julian and I had a chance to play some music together. I'm a trombonist, and went to the San Francisco Conservatory of Music and was a gigging musician for a lot of years. And after that became a piano tuner. And I felt that learning what it took to become a piano tuner helped me so much to understand sound and music and tuning that I have been inspired to create this talk that I'm going to give you today, to try in 50 short minutes to give you an idea of the difference between thinking about sound as a musician and thinking about sound as a tuner, and how those two worlds can meet. So the basic premise of my talk is to familiarize you with the idea of overtones, because that's often what's sort of mysterious and unknown to people. And let me tell you, that's where tuning is. That's where you will focus when you get sophisticated in your tuning. So my hope is by the end of this lecture that you will have an awareness of overtones and some specific techniques that you can use when you're in your ensemble, when you're in your rehearsals, to help you play more in tune. So a few introductory remarks about this. You know, as a piano tuner, one of the interesting things is that people will come up to you and they'll have some theory of tuning, because everybody's trying to play in tune. And seldom do they really understand the physics of sound. And so people will come up with strange ideas, and it's always fascinating for me to hear what people have to say. Every year some student will come up and say, you know, I saw on a YouTube video that the ratio of the sides of the pyramid are, you know, perfectly in tune with the chakra, heart chakra, something to do with the Illuminati. I mean, there's all these like out there theories about tuning. And so a big goal of this talk is to try to not necessarily debunk, but maybe give you a scientific basis for your thinking about tuning. So then if you want to go with the Illuminati or with the music of the spheres or whatever, great. But you'll have some scientific idea, some fundamental concept and understanding of music and physics. So, and then there are a few strange things that are often misunderstood. Like, for example, if you are playing in an ensemble and you're playing a note that's in tune and the chord changes and suddenly you're out of tune, like, what's that all about? Right? And obviously the other people have gone out of tune, right? Because you were in tune, so you're still in tune. No, no, no. You probably needed to change something because the chord changes. So that's something that is difficult to illustrate unless you know the physics. I know I went to a very nice music school, and the tuning instruction I got was basically, come on, tune it up, listen, which isn't bad, you know, because sometimes we forget to listen. We're so involved in playing. It's not bad advice, but there's a lot more that you can know that will give you specific things to listen for. Okay, so let's start at the very basic level of what is sound. That might sound like a dumb question, but I'm going to make a sound right now. That's it. So what just happened? What was that? Okay, well, first of all, in order for there to be sound, there has to be a medium. There has to be something for sound to travel through. So out in outer space, there's no sound, because it's void, there's nothing. But here we have air, and air is a pretty good medium for sound. So what is air? Air is a space with a whole bunch of molecules of different kinds kind of floating around. And if you close up this room and everybody leaves and it sits for a couple of hours, the molecules will more or less distribute themselves equally, and the room will just sit here quiet and equally balanced. And as soon as someone walks into the room, there will be waves and currents of molecules going around. And if something fairly violent like this happens, those molecules get compressed into sort of like an area like that. The area right around my hand, the molecules got compressed together. But that little pocket of compressed molecules didn't just stay around my hands and float there. No, it moved out, and it got to your ear. And the thing about these molecules is that they have weight, they have mass. And so when that pocket of compressed molecules hit your eardrum went, it moved, it physically moved. And then we have this amazing circuitry of nerves and bones and tubes and fluids that connect to our brains. And then we have our genius brain that can interpret that sound. And your brain says, somebody just clapped their hands. So that's what sound is. It's the physical movement of air. You know, we don't think about air having weight, but it does. Think about a hurricane that can blow over semi-tractors, blow houses over. Air has a tremendous amount of mass, and if it gets moving, it can really move stuff. That's why you can hurt yourself if you're near an explosion. It can blow your eardrum out. So the weight of air is very important, and that's what sound is. Okay, sound. So what's musical sound? How would you define musical sound? Okay, well, let's call this a beat for our purposes. So in other words, it's beating on your eardrum, just like a drum. It's a beat. It's coming, it's hit your eardrum like a beat. If you have regular intervals of beats, I'm using that to define musical sound. You have a regular interval. It's not like beat, 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 beat. It's a regular interval of sound, of beats, is a musical sound. So when we talk about A440, that's exactly what we're talking about. We're talking about 440 beats striking your eardrum every second. 440 per second. Pretty amazing, isn't it? That's fast. And that's, you know, just in the middle of the keyboard. The human ear can hear up to about 20,000 beats per second. So our ears are really remarkable, all the way down to, this is about 23 beats per second. And you can still discern a pitch there. So again, the human ear is capable of a really wide range of discerning pitch. And that's all pitch is. It doesn't matter whether it's lips vibrating in a tuba, or if it's playing cards in the spokes of a bicycle, or playing with a bow, whatever, or the strings on a piano. Whatever can move the air 440 beats a second is playing an A. That's all pitch is. What is an interval then? Well, an interval is a ratio of beat rates. So you have a beat rate. I like to go A440 because that's what most people know. They say, oh, let's tune to A440. So a simple ratio, the most simple ratio, is what? It's 1 to 1, right? So if you have one instrument playing A440, and another instrument playing A440, they're playing in unison. That's 1 to 1. And what's the next most simple whole tone ratio? 2 to 1. That's an octave. That's the only definition of an octave. That's what an octave is. So if you're playing A440, somebody else plays A880, they've gone up an octave. Somebody else plays an octave, an A220, they've gone down an octave. That's it. Three to 1 is the octave plus fifth. Did I just spell fifth wrong? Rhymes with Sith. And again, that's the only definition of that interval. And then you can play around with this. For example, if that's the octave in the fifth, what's just a fifth? Well, it would be 1.5. Half of this to 1 equals a fifth. And by the way, the math doesn't get like harder than this, so don't worry when you see numbers. It really stays this simple. It's pretty remarkable. And then, of course, there are ratios for every interval that we have, and every interval. I'm giving you the most basic and the most simple ones. Okay, so dissonance. So far we've been in a happy world where everything is perfect and in tune. But in the real world, music is almost always somewhat dissonant. So what is dissonance? Okay, so if we imagine my fingers to be those beats that I was talking about, those physical beats that actually exist in the air, and someone is playing an instrument and a note is happening, and those beats are traveling through the air, and you see how they're pretty much equidistant because it's a musical note, and they're traveling through the air like this to the audience. And a second person is playing almost the same note, but it's not quite the same. How can I do this? So it's traveling a little bit faster. It's a little sharp of the first guy. So what's going to happen? They start out together, and as they go, this guy's going a little faster. Oh, they're not together now. And now, oh, now they're together again. And now, oh, now they're not together. Now they're together again. And they're going to phase in, and they're going to phase out. When they're phased in, they're going to reinforce each other and make the signal strength stronger, which means louder. When they're directly out of phase, they're going to sap energy from each other, theoretically to the point of silence. And so what do you get? You get that sound. Do I really need to play that sound? Yeah, I'll play that sound. Why is that a shimmering sound? Because of the phenomenon I just talked about. Because it's getting stronger and weaker. That's what dissonance is. Two pitches that are close enough, but not quite. And as they get closer to each other, what happens? What happens to the beat of the dissonance? It gets slower as they get closer to each other. As they go farther out of tune, it gets faster. And as they get closer to each other, it slows down until it disappears. It disappears eventually. So that's clue number one on on thinking about tuning is if you are if you're out of tune and you make an adjustment and the beat rate gets faster, you've gone the wrong way. You're going to adjust the other way. And furthermore, it's unlikely that you'll be able to discern which way to go. I can tell you that because after years of piano tuning, I still experiment. I do it by guess and by golly. I think I'm high, so I go down, but I'm not always right. If you have a unison, it's very hard to hear which way to go. So it's a matter of experimenting. And you can do this very quickly with practice. So we'll be talking about practical applications of this, but the answer to dissonance is to listen very carefully to the cause and effect of your changes and to determine very quickly which way to go. Okay, and then one more thing I want to discuss regarding pitch, and that is when we're practicing with our tuners, what are our tuners calibrated in? They're calibrated in these things called cents. So what is that? Cents is not beats per second. It's not the pitch rate. So beats per second is, in the case of A, tuning A, 440. So you can call it
440 beats per second, or you can call it 440 hertz. If you ever see that term, hertz, it's just another word for beats per second, 440 hertz. But that's not what a cent is. Your tuners are calibrated in what piano tuners use, in cents. A cent is 1/100th of a half step. Pretty small increment. 1/100th of a half step, or 1/1200th of an octave. So a cent is very small. So if you're working with your tuner and you're a couple cents off, you're good. You're really good. So it will be good for your tuning and good for your mental health to give yourself a range on your tuners. Julian can, I think, agree with this. My personal suggestion is 2 up and 2 down. As you're working with your tuner, if you don't stop and freak out if you're a cent or 2 sharp or flat. Call it good. If you're in that range consistently, you're going to be darn good. You've learned your instrument, which is all a tuner is good for. One other comment about cents is sometimes people want to tune not at A440. Maybe they have an idea that they want to do an historical temperament. Maybe they want to tune at A438 or 435. And they've got this tuner in cents. So how do you correlate cents? Well, at A440 there's an easy one. 4 cents equals 1 hertz. Okay? So if you want to tune at A439, you tune 4 cents flat. If you want to tune at A441, you tune 4 cents sharp. 442, 8 cents sharp. Okay, now, all of that really is sort of like the groundwork for what I really want to talk about, which is overtones. Because I think that overtones are some of the most misunderstood and not believed in, and people say, oh, I can't hear overtones, or they have some idea like, yeah, that instrument has overtones, but this one doesn't, and there's all these cockamamie ideas about overtones. And the fact is that we do hear overtones all the time. I'm going to sing a note right now for your pleasure. And afterward, and I want you to close your eyes and listen very carefully. I'm going to sing in a very special way. And I want you, by a raise of hands, tell me who hears the overtones. Ready? Oh. Now please raise your hand if you heard the overtones. A couple tentative people. Good, good. Actually, this is a great class. That's a better response than I usually get. But the fact is that all of you should have absolutely raised your hands. You all totally heard the overtones, 100%. And the reason I can assure you of that is that you didn't confuse me with a trombone or a piano or a bassoon, right? All those instruments can play the same note I just sang. But there was no question in your mind, right, that it was that guy singing that note. Right? There was no question about that. You heard the overtones. It was the overtones that told you what the source was. Again, your brain has learned, oh, that sound, guy singing. Oh, that sound, bassoon. We are really geniuses at hearing overtones. I don't know why, but human beings are incredibly sensitive to overtones. So, for example, if your friend comes up behind you in the hall and says, hey, how's it going? You don't have to turn around to know who that person is, do you? You know who they are. And yet how different, like if you did a spectrograph of their voice, let's say it's a young man, how different would that spectrograph be from other young men's voices? You know, if you plotted it out, it'd probably be really similar. But there are enough little clues to tell you, oh, that's Biff. pretty amazing, really, when you think about it. But we're even more refined than that, because if Biff comes up behind you with a little cold, he says, "Hey, how's it going?" You go, "Oh, Biff, man, you got a little cold, huh?" Now, what's the difference between the spectrograph of Biff's healthy voice and Biff's voice with a cold? Like, not much different. But you don't have to, like, work hard. You instantly hear, oh, he's got a cold. Think about it. Pretty remarkable. We're geniuses. But it's even more refined than that. Because let's say Biff has a bad cold. You come, "Oh, hi, how's it going?" You turn around and you say, "Wow, your cold's gotten worse, hasn't it? Yesterday you had a little cold, today you got a bad cold." Now, what's the spectral difference between Biff with a bad cold and Biff with a not? But you see what I'm saying? It's remarkable what we can hear. It makes my job murder, tuning pianos, because we're so sensitive to sound, and particularly sensitive to overtones. So you do hear overtones, I guarantee you. Okay, so what are overtones? Sound generates overtones. All sounds, unless they are electronically generated to not have overtones, we'll just forget about those. Natural sounds create overtones. And the overtone series follows this ratio. So if you, let's say that we're going to play we're in bass clef here. And let's say we play a C on an instrument. Then the first overtone will be the octave C. It will be automatically generated by that pitch, the 2-to-1. And then the 3-to-1, the octave and a fifth. And then you probably can guess that the 4-to-1 is the double octave. And then 5-to-1 is the octave and third. And then there's the octave and fifth. And then there's the weird tone that's not in Western music, that's sort of like a seventh. And then there's the triple octave, quadruple octave. And it goes on from there, theoretically forever. But in the audible range up to, depending on your hearing, your young ears can probably hear better than 20,000 hertz. So whenever a sound is generated like that note I just sang for you, it's really like a choir. There's all these other pitches that are there all the time. So you might ask, so if every pitch generates exactly the same overtones, why don't they all sound the same? And that's because the signal strength of the different overtones varies dramatically. So, you know, these lower overtones always tend to be kind of strong. But again, we're talking about, you know, if you were to look at the keyboard, we're talking about notes that go probably 3 or 4 keyboards more. And when you get up into that range, there's a lot of variation in signal strength. And so, you know, theoretically, there's sort of an infinite color spectrum of sound that could be created. When you think of all the variables and all the different signal strengths, this one might be almost gone. This one might be really strong. This might be halfway. When you put all those together in the infinite permutations of all those things, you get the wide world of sound. Pretty straightforward so far, huh? Okay, now, temperament. This is a term that you might hear. What temperament are you using? Are we playing tempered? What's the best temperament? What is temperament? So, thus far in this talk, what I've been talking about is sort of perfect tuning in accordance with the natural overtones. The term for that is just. That is just tuning. And the word just isn't used in the sense of it's just tuning. It's used in the term of like justice. That is a just tuning. It's perfect in accordance with the overtones. It's beatless. There's no dissonance. All of the overtones are in tune with each other. But there's a problem when you get to a fixed pitch instrument like a piano or a guitar. You can't tune just. Why not? Well, because there's an interesting mathematical phenomenon where if you start at this C and you tune perfect 2-to-1 octaves, you get to a certain place here. You get to a multiple of the first one, and you arrive at a certain pitch for this C. If you start at this C again, and you tune perfect 1.5 to 1/5, you do a stack of those, I get to C again, but it's a different C. It's a different pitch. And that just has to do with the math of it. If you take a bunch of, if you double and double and double and double and double, and if you do 1.5 and 1.5 and 1.5, you never get to the same place. Never. It never happens. It's a radical. So you get to what's called a comma. You have one C that's the result of the stacks of octaves and one C that's the result of the stacks of fifths. So you can't make perfect octaves and perfect fifths on a fixed pitch instrument. So what do you have to do? You have to compromise. You have to rob from Peter and rob from Paul and rob from Mary and come up with something that's acceptable to everybody, but nobody's perfectly happy. So that's what temperament is. A synonym for temperament is compromise. So the temperament that's most commonly used, the temperament that's on this piano, is equal temperament. And a good definition of equal temperament is every key is equally out of tune. So C major, C sharp major, D major are going to be equally out of tune. The beat rates of the individual intervals in those triads will be equally out of tune. And it's not a little bit, it's a lot. It's quite out of tune. So let me just play this piano a little bit. This piano's fairly in tune. Some guy came and tuned it a while back. So, you know, it's into, that's what we think of as piano. That's what a piano sounds like, right? Okay. Let me demonstrate how out of tune this piano is. When I'm doing aural tuning, I get my A from my fork, A440, I do my octave, and then my first tuning interval is that third, F to A. And I make it beat 7 beats a second. That's incredibly out of tune. 7 beats a second is about as fast as you can count to 7. 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7. It's not a little bit out of tune, it's shriekingly out of tune. And that is correct. That's what you heard when I was just playing. That's what you hear every time you hear any recording of any piano. You're hearing that. So I'm going to demonstrate that for you right now. I have muted off 2 of the strings of the A so that I can change it. And I'm going to lower that A so that it becomes just, so that the beats go away. And then I'm going to raise it again so that the beats come back. And I'd like to ask you please again to close your eyes and see what you hear. See what you hear. Hear what you see. So there's the 7 beats a second. I'm going down now. That's a just third. There are no beats. I'm going to bring the beats back in now, very slowly. Listen, please. You're going to hear it way up here, way up in this overtone. Listen, way up there. I'm going to go down now to just. Now listen at this point, and you'll start to hear a beat at that pitch. I'm going to do one more time. I'm going to go down. Be sure you're listening here. Ignore this, and only listen here. That's just. Now I'm going to temper it. I hope that most of you are hearing that. Don't freak out if you're not, because it's a weird way to listen and it's a new way to hear music. But this is the way I'd like you to train yourself to learn. I think I'm mostly getting nods of the head, so it's not really that hard. I think most of you are getting it, right? And then when you're playing in an ensemble, you can do this too. It's not just a piano thing. You know, overtones are in everything. So you can listen for those overtones and it will tell you when you're out of tune. Okay, now let me demonstrate why I have to temper. So let me take this back down to just. I mean, let me just say that if I played that third in an orchestra, or if Julian did, they'd be like, next. You know, that's just unacceptable. If you're playing in a brass quintet or a string quartet or singing in a choir, you're going to have to sing just. But on a piano or a harp or a guitar or an organ or a fixed pitch instrument, that's what we're stuck with. So anyway, let me take this to just. Sounds pretty good. That sounds right to me. Oh. It's really different from... Hear it now? That's F sharp. I haven't changed it. Isn't that nice? That's just. That's not. Okay, but why can't I leave the A there? Because the A doesn't only function as the third in the key of F, it also functions as the fifth in the key of D, and if I leave it low like that, I get an unacceptable wolf interval in the key of... Can't do it. So to make that fifth sound good, I got to raise the A back up to about there, and now I'm back at a beating F chord. That's temperament. That's why we have to do it. That's what you will have to deal with. Every time you perform with a piano, you'll have to be aware that there are different tunings out there. If you're playing in a, like I said, in an ensemble that has movable pitch instruments like brass quartet, string quartet, etc., you'll want to go for just. And if you're going to play with the piano, you're going to want to go for temperament. And we'll have time. We're doing pretty well with time, actually. I'll talk about different techniques for that problem. But it is a problem, and it's very good to be aware of it. Okay, so far I've been discussing equal temperament, but of course, all temperaments are not equal. There's no reason that you can't favor some keys. You can make F major sound pretty good, or even perfect. And you can make a whole cluster of keys sound pretty good around F, and then there's going to be a cost. You're going to have some keys that sound pretty bad. And so you'll hear about these various tunings. There's, mean tone tuning and Kierenberger. There's literally hundreds. Anything you can dream up is a temperament. You could make everything terrible except for C major, whatever you want to do. Whatever is acceptable to the musicians that you're performing with, or who you're tuning for, I should say. So I've occasionally had artists who required an unequal temperament, and I've done my best to provide it for them. So there's not general agreement about this. But there is a question that comes up a lot. Every year students and everybody comes up to me and says, what's the best temperament? Is equal temperament the best? And my answer is that if just intonation is the Mona Lisa, it's perfect beauty, exactly right, then any temperament is a mustache on the Mona Lisa. It's a defacing of the Mona Lisa. So if you prefer a Hitler mustache on the Mona Lisa, great. Or if you'd rather see a Fu Manchu, great. Or a waxed handlebar, whatever. It's just shades of defacement at that point. It's just, that's an opinion. And I don't have I do have an opinion, actually. I think equal temperament is probably the best, because in a modern concert, the concert artist on piano, the concert artist is called on to play Bach, and then they're called on to play Liszt, and then they're called on to play Schoenberg. Vastly different genres. And my opinion is that probably equal temperament is the best choice for that. But that's just an opinion. And Peter Serkin, who is, a world-renowned artist who came here to play Schoenberg, wanted which is a tone row, which has no tone to it, no tone center, wanted an unequal temperament. So that was his opinion. And his opinion trumped mine. I did it. So really, there is no best temperament. Equal temperament is the standard. It's the default. Unless someone asks me specifically to do another temperament, I'll do equal temperament, and it's what you've mostly heard on recordings and on all the pianos here and everywhere you'll go. One crucial point that I haven't really emphasized yet, maybe you got this already, but I demonstrated dissonance, and I talked about dissonance, and I think you understand what dissonance is. Dissonance is not only something that happens at the fundamental. If you can hear dissonance at the fundamental, like I demonstrated there, that's grotesque dissonance. You're probably, I assume, as college students, not going to sound like that. That's like elementary school sound like that, because their fundamentals are super out of tune. You've pretty much practiced. You've practiced with your tuners. You know how to play your instruments. You're more or less in tune. If you're out of tune, it'll be the overtones that are dissonant. And overtones are can be very audibly dissonant. So let me demonstrate that. Most of the time I spend on the piano is refining the unisons so that they sound very clean and nice. So in other words, I'm not going there. That's where you're hearing the fundamental. You're hearing bop, you're hearing the actual pitch beating. Most of my life is spent when I get about to that point. And can you hear, various people experience it a different way. I feel it's like a cat's meow. 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 Hear it? It's really irritating. And it's really tedious to get rid of it because it's a tiny, the fundamental is in tune. You're not hearing the fundamental beat. You're hearing a really high overtone that's out of tune. Let me see if I can get rid of it here. Pretty good. So when I say that tuning is in the overtones, that's what I'm talking about. Because I'm not talking about getting to the point where that's gone. I'm talking about getting to the point where that cat's meow is gone. And when you can hear those overtones, when you're sitting next to your standmate or whatever, or you're in a chamber ensemble with someone, and you're hearing that cat's meow and you're refining it, you're going to be playing at professional level. That's the cut between the people that are really good, like talented, yeah, good for you, and the people that are like on records, who are touring around, because they're doing that. They're hearing that. Whether they're aware of it, I have no idea. Some are and some aren't. I've heard some funny theories from really good musicians. The one I mentioned here at the top of your handout is I had a very accomplished violinist wanted to talk about tuning with me, and they said, yeah, what I do is if all the flats I tune sharp, and all the sharps I tune flat. And I'm here to tell you that that has no basis in anything. That's not physics. There's nothing there. That's what they thought they were doing. They weren't. I just heard them perform. They were beautifully in tune. So whatever their theory was, in practice, they were listening and they were doing what I just did there. They were listening to the overtones and isolating those overtones and getting them in tune. So far, I've been talking about stacks, haven't I? Everything that I've been talking about has been vertical. Stack and stack and stack and stack and stack. But, for us trombone players, for most people who play a single note instrument, you're not playing stacks of notes. You're playing a line, right? There's also horizontal tuning. And that has its own issues. For example, the leading tone, the seventh note of the scale, is called the leading tone for a reason. You get up to the leading tone and it just wants to draw into the one. The seven wants to step on into the one. It leads to the one. and it's crying out to be played sharp. You want to play that note sharp. It's called the leading tone. So the line demands that that note be played sharp. But there's a big problem, isn't there? Because if you're playing the 7th note of the scale, harmonically, you're probably the 3rd of a 5 chord. What? That's going to resolve. And the thirds want to be played low. And when I say low or high, that's in comparison with equal temperament. So if you're the 3rd of a chord, you're going to want to go down. If you're the leading tone, you're going to want to go up. What do? That's a direct conflict. My advice is that if you are very prominent, you're kind of the leading voice, you have the melody, and you're moving pretty quickly, play that leading tone on the bleedingly high edge of in tune so that it goes right into the 1. If you're going to linger on that note for a long time, and you're the 3rd of the chord, please don't play it bleedingly high, because it will sound really bad. Play it low, and then just resolve it the best you can. Another thought about working with your tuners. What's the big problem with tuners? I've already talked about fixed pitch instruments, pianos, organs, guitars. Well, your tuner's a fixed pitch instrument, isn't it? It only gives you 1A, doesn't it? It's a fixed pitch instrument. So don't think that you're going to become a sophisticated tuner using your little $50 Seiko tuner. It's not going to happen. Please don't go into rehearsals and put your tuner there on your stand while you're playing. And please don't argue with people and say, look, I'm in tune. Don't do it. You're probably not in tune. The only way to be in tune is these techniques that I'm talking about. Know where you are in the chord. Listen to the overtones. Listen to the people you're playing with. And fit in with them. That's what tuning is. It's not an absolute thing. Use your tuners to learn the basic notes on your instrument. And then there's no substitute for listening and knowing where you are in the chord. Your teacher will teach you what parts of the chord are what. Thirds are low. Sevenths tend to be low. Fifths tend to be a little bit high. So expressive tuning, vertical and horizontal tuning, intentionally playing out of tune. This is really getting into where when you feel really comfortable enough with tuning, you can be incredibly expressive with tuning. If you look at the bottom, I have further reading and listening. I've said Sarah Vaughan versus Ella Fitzgerald. Now, Ella Fitzgerald, if you listen to her, they're both great, genius jazz singers. Ella Fitzgerald will scat sing, and regardless of how fast and how lively her singing is, every note will be in tune like a diamond. Perfect. Sarah Vaughan will hit a note low and stay low and maybe resolve it up a little bit. She plays with the intonation. It gives her a moody, smoky, colorful, sexy, dark, meaningful sound to it. Tuning is incredibly expressive. Another example, I can't tell you how many times I've been in the airport or in an elevator and I hear the Muzak playing like Stevie Wonder or something. And it just never sounds good. You know, I don't care how good the musicians are, I don't care how interesting the arrangement is, it just doesn't sound like rock and roll. It doesn't sound like the blues. Why? Because the tuning's wrong. They're playing it with a Mozart tuning. I think it's fair to say that America has developed its own temperament. I call it the African American temperament. People say the blues note, the blue note. What's the blue note? Is that, oh, it's the minor third. No, it's the whole tuning attitude that African Americans brought to the West. Before that, we had Mozart. We had nice, clean tuning. And it was the African Americans that came and played with that. And so if you play the blues, rock and roll, with a Western tuning, it doesn't sound right. So tuning is expressive, and you can use it as such. And then one quick note about, I promised you I'd talk about just and tempered. So you practice in your practice room and you're trying to play the notes right, you play just, then you get with the piano and it's tempered. So what do? Well, my opinion is if you, again, are prominent and moving quickly, and it's really all about you, and the piano is just accompanying you, play just. Play that so that it sounds correctly in tune. And if it's more of a collaborative, if it's a duet time, when you're really equal partners, then listen to the piano and play in a more tempered way, more like your tuners. And again, that's an artistic decision that you'll make minute by minute, probably not even do it the same way twice. But be aware of the difference between just and tempered and intentionally make those choices. Okay, thank you so much. It's really been a pleasure to talk to you.